All right, so for 3.3, we're talking about the first derivative tests. Starting off with this theorem, talking about, yet again, starting off talking about a continuous and differentiable function. Right? If we have a continuous and differentiable function, then the following is true. If the derivative of f of x is greater than 0 for every x in that interval, then f is increasing on that interval. All right. In other words, if the derivative is positive, the original function is increasing, which should make sense because if the derivative is positive, that means the slope of the tangent line is positive. So the graph is increasing, it's going up. If the derivative of f of x is less than 0, then f is decreasing. So the original graph would be decreasing. So derivative is negative. Then f is decreasing. On that interval. So let's look at an example down here of a graph. If we look at this graph, we're going to have a few points where we have critical values, where the derivative is 0. Right, so here, 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 and here, each one of these points, the derivative equals 0. We talked about critical values last week. Critical values occur when the derivative is 0 or the derivative does not exist. And those critical values tend to be local minimums and local maximums. Not always, but a lot of times they are. So that's what occurs here. We have some local maximums and local minimums. Now what you'll notice, in between these critical values, in between these minimums and maximums, the graph is doing the same thing the whole time. It's either increasing the whole time or decreasing the whole time. So if we look at the very left side of the graph, as we keep going to the right until that first point where the derivative is 0, that whole time, what's going on with the function? It's increasing, right? F is increasing, and the derivative of f is greater than 0, right? The derivative is positive. It has a positive slope. The graph is increasing. Right? That also occurs between these two critical values and to the right of this critical value. So in each one of those spots, the derivative is greater than 0 and f is increasing. Right, so those go hand in hand. Now, we also have some intervals where the derivative is negative and the function is decreasing. So here the derivative f is less than 0, right? It's negative, and f is decreasing. That happens right here in this blue highlighted portion as well. The derivative of f is less than 0, f is decreasing. Right, so that's easy to see with the graph, okay? It's increasing, decreasing, and you did that a little bit in pre-calc before, but today we're going to look at how to do it without looking at that graph, without necessarily having a graphing calculator. So there's 3 kind of steps to do this. First, we're going to find the critical values, which we've been working on for a while. Then we're going to draw a number line and label the critical values on the number line, and then test some values between the critical values and substitute them into the derivative to see if the function is increasing. If we see that it has a positive derivative, that means it's increasing because it has a positive slope. Or if it's decreasing, negative derivative tells us it's a negative slope and it's decreasing. All right, so like I said earlier, in between those critical values, things are happening the same way. All of this, like to the left of this critical value, the whole function's increasing that whole time. Between these two, it's decreasing the whole time. Between these two, it's increasing. So that's going to happen with critical values. It's always going to be the same in between or to the left or right of them as we go.